Okay, here's an example of looking at type 1 and type 2 errors from a hypothesis test, and in this case it's a discrete example. So if we look at the question, two athletes A and B have met 15 times in the same event. A had the fastest time on 11 occasions, but B claims there was nothing between them. In a forthcoming meeting, they're going to compete in 3 races, and it's decided to test whether B is the same standard as A, or whether previous results are a more valid measure of their ability. So, what's happening here? Well, the test is going to be based on a binomial. Okay, they're having 3 races, and we're testing who is better. So we're testing the probability of one of them winning. So in this question, I think it needs to be clearly defined what P is. So I'm going to say that P is the probability that A wins. There's no harm in you putting B wins, but you need to be clear what you're doing. So we'll come to the errors in a minute. Let's talk about our test. So our null hypothesis is that there's nothing between them. So the chances of P winning, probability of A winning, are equal to B winning. So the chance of success, which is A winning, needs to be a half. The alternative hypothesis, we need to have a different value of P in here. So as we're saying, previous results are a more valid measure. Previous results had A winning 11 out of 15. So the probability of A winning in those results was 11 out of 15. So that's the test we're carrying out. So as I've said, when you're doing type 1 and type 2 errors, I'd always write down what's happening. So the probability of a type 1 error is the probability of rejecting H0 given that H0 is true. So it's the chance of rejecting a value for rejecting H0 when it's in fact true. So now let's think about what that means in the context of our hypothesis test here. So when are we going to reject H0? Well, it says here H0 will be accepted if B obtains a faster time, so therefore it will be rejected if B doesn't obtain a faster time, i.e. if A wins all of the races. So we're looking for the probability that X equals 3, okay, which is A winning all the races, given that H0 is true. So what if H0 is true, this probability is true, so given that P equals a half. So it's a binomial. So we're looking for the probability that X equals 3 given that, which is the same as 1 minus the probability that X is less than or equal to 2, given that P equals a half, which is 1 minus the binomial CDF of, let me check what we have to put in. So we're doing 1 minus second distribution binomial CDF. Trials is 3. We're saying probability of success is 0.5, and we're looking for less or equal to 2. So 0.5, 2, 3, 0.52. So we get 0.125, which should also make sense if we show a bit more working. We think about it. If X wins all 3, that means it's a half cubed, which is an eighth, which is 0.125. So there's a 12.5% chance of making a type 1 error, of rejecting H0 when in fact it's true. So there's a 12.5% chance from this test that we're going to say that actually A is faster when in fact there's nothing between them. Type 2 error, always the more challenging one. Probability of a type 2 error. So what is a type 2 error? Well, it's accepting H0 when, in fact, H0 is false. So again, I'd always write this down and then think about the context of the question. So when are we accepting H0? H0 will be accepted if B obtains a faster time. So in terms of A winning, we want to make sure that A doesn't win all of them. So we're looking for the probability that X is less than or equal to 2, which means that B will have won at least 1. Given that H0 is false, well, if H0 is false, this value of P is then true. So given that P equals 11 over 15, so we can go straight into a binomial CDF. Probability X is less than or equal to 2, so 3 trials. Probability of success is this time 11 over 15, assuming this, and we're looking for 2 successes, which gives us, and then you'll see we have 3 trials. This time probability of success is 11 over 15. So 0.606 to 3 significant figures. So it's actually a 60.6, 61% chance of us accepting H0 when in fact it's false. So there's actually quite a big chance of us saying actually these two people are the same ability, when in fact A is better and A wins 11 out of 15 races.